Hi everyone, welcome to the last part of Chapter 1. Today we're going to review research designs just a little bit. We left off in the last lecture talking about experimental research. We covered that in depth. Remember, we looked at all the different variables that are either manipulated or recorded in some way in an experiment, and those nasty little things called confounds. Anyways, I want to spend just a couple minutes reviewing experiments, and then we're going to dive into the descriptive research methodology. And the reason, again, why we're doing this is because which research design you choose can tell you which statistics are appropriate. All right. Now, I also mentioned last class that even though we have a certain set of statistics that are common to descriptive research paradigms, they can be used in experimental research and vice versa. So we have some statistics here that we commonly use, but they can, in certain situations, be used in descriptive research. All right, so after we do this review and cover the descriptive research designs, we're going to turn our attention to numbers themselves, because so far we've been talking a lot about variables, but not the numbers. And so we're going to spend a little bit of time on that, and then we're going to conclude with something called deceptive statistics or misleading statistics. All right? Okay, so just as a fast review then, experimental research, remember that you are manipulating variables. Do you remember what that's called? What that variable is called if you manipulate it? That's the independent variable. And by manipulate, we mean creating groups or conditions to be compared. And those different groups or conditions are referred to as levels. So an independent variable is manipulated, and you have to have a minimum of 2 levels that you're going to compare. The variables that are recorded are the dependent variables. The dependent variables are the ones that you think are going to be impacted by the independent variable. All right, and then let's see what else. We talked about how variables in the experiment are controlled as much as possible. So experimental research, it's all about control. So you're controlling extraneous variables. Remember that? So extraneous variables are any variable present in your experiment other than the independent or dependent variable. So once you've identified independent and dependent, any other variable would be called extraneous. Let's see. And then participants, this is the hallmark of a true experiment. If participants are randomly assigned to the different groups, or if they could be randomly assigned. Now, there is one thing I'll sneak in here that I didn't talk about last class, is that sometimes an independent variable in some ways cannot be randomly assigned because each participant is tested in each level. Let me give you a quick example. Let's say I want to know, do you do better in a room that's painted, I don't know, green versus a room that's painted red? So we're looking at test scores here, and I'm manipulating the color of the room. So I think room color, the independent variable, might have an effect on your test scores. Well, what if I decide that I'm going to test everybody in the red room and everybody in the green room? All right. The only thing that I can do in this type of manipulation is I can randomly assign you to begin with one room. So maybe half of you are going to begin in the red room. You get tested there first, and then you get tested in the green room. The other half, it's going to be the opposite order. You start in the green room, and then you get tested in the red room. All right, so it can be a little confusing sometimes because people say, well, there's no random assignment to groups because everybody got the red room and everybody got the green room, so you're not randomly splitting them up. And that's true. But the color of the room is still considered to be a true independent variable, even though I didn't randomly split the participants up. All right, everybody got tested in the same room. The reason why it's considered a true independent variable is because I could have decided, you know what, I'm just going to randomly divide the class in half, and half go to the red, half go to the green. All right, so I could have structured it differently so that instead of everybody being tested in each room, I could have randomly assigned you one half to the red, one half to the green. So it's still a true independent variable, even though the first way I ran it, I didn't randomly assign you to a room. You got tested in both rooms. Okay? If that's confusing, let it sit, let it digest. If it's not digesting well, then go ahead, reach out to me or the intern, and we'll give you some other examples and elaborate a little bit more. Okay? All right, so the hallmark then of a true experiment is where participants are randomly assigned to the different groups or the different levels. And that's called a true IV. A true independent variable is one where that random assignment has taken place. Now, if it's the case where participants they can't possibly be randomly assigned to the levels of the independent variable because of some pre-existing condition, let's say biological sex. If I'm studying sex, male versus female, I can't randomly assign you to be one or the other. It's impossible, with current day technology. So in a case like that, with that pre-existing condition, then we would call that a subject variable or a classification variable. And do you remember, if you run an experiment where you just have a subject independent variable or classification independent variable, do you remember what that's called? It's called a quasi-experiment. Okay, but in all other respects, it looks just like an experiment, a true experiment. All right, so we've defined independent variables, dependent variables, extraneous variables, and then we have confounds. And we spent quite a bit of time understanding how an extraneous variable could become a confound. And we discovered that an extraneous variable can become a confound, but only if it is systematically different between the groups. So we went through a whole whack of examples. If you don't understand or don't remember or whatever, go back, look at that. And if you are still dumbfounded by the whole explanation, then please reach out. Okay. So let's see, then we said that in experiments and quasi-experiments, typically what you're doing is you're using statistics to see if the means for the different groups are different from each other, right? So whether or not the levels are different beyond chance, and we'll cover that later in the course. The strength is that experiments and quasi-experiments, but more so experiments, true experiments, get as close to cause and effect as you possibly can get. And the weakness is uncertain generalizability, because the experimental situations are such that we're trying to control everything, which makes the environment, the situation, very artificial. So the results may not generalize very well to the quote-unquote real world. All right, so what we're going to do now is we are going to turn our attention to descriptive research, and we're going to hit on each and every one of these characteristics for the most part.